This week, we will look at broken scaling laws, surgical fine-tuning, and interpretability in the wild, as well as threat models of AI. Today is November the 4th, and this is the ML and AI Safety Update. Quite a lot of interesting papers have been making the rounds out there the previous weeks, and we have selected a few of the most interesting ones for you. First, let us look at one about broken scaling laws. So scaling laws are important to infer how future AI systems will behave, and right now existing scaling laws are often fitted linearly or monotonically. But as a critique of this view, Caparello and Krüger and others are introducing broken scaling laws, since they do not find that normal scaling laws research reflect the empirical facts of model training right now. So their new broken laws function can show breaks which correspond to the sudden non-monotonic shifts in ability we see from neural networks. Their function extrapolates significantly better than other function forms. Robustness of computer visions is important for a range of tasks. A team from Stanford has shown that fine-tuning single layers works better than fine-tuning the whole neural network in specific adversarial benchmarks. For example, surgically fine-tuning early layers give better performance for input levels, shifts such as corruption attacks, while late layer fine-tuning induces robustness for output level shifts. Parrish, Bowman, and others has also shown that debate does not necessarily help humans answer hard reading comprehension questions. In their study, they helped participants by showing them arguments for and against an incorrect and a correct answer to a question. But they found that humans do not benefit from this. When Drake and Jojen went to the store, Jojen gave a drink too. A transformer can easily predict that the next word in this sentence is Drake, but how does it do it? Redwood research identifies a circuit of conceptual understanding in the transformer heads. We see that the neural heads have specific functions in understanding. Some identify duplicate words, some inhibit specific words, and the three late-stage classes of heads negatively and positively move the word Drake into the predicted position. This is called indirect object identification and is clearly an interesting test case for circuits interpretability. Moving on, the DeepMind safety team has created a taxonomy of how the current risks look from artificial intelligence. Their consensus development model is a scaled-up version of our current models, which they don't think need much innovation to become an AGI, a so-called artificial general intelligence. The risks that arise from such a model are goal misgeneralization, where the models fail to generalize their training to real-world scenarios, and are power seeking as a result of such misalignment. We do not expect to catch this due to deception, and the most important people in society won't understand the risk. John Wentworth notes that this multi-stage story is not even necessary, since current systems already train to deceive humans. Also, Michael Cohen has shown that the risk of an existential catastrophe from AI is above 35%. He though takes an optimistic perspective from the success scenarios such as well-enforced laws that stop dangerous versions of AI, an entity that stops it in some way, that no one develops advanced AI, or that an advanced AI is developed in a safe way. The latter rests on assumptions that focus on the ability of the AI to make hypotheses, follow plans in uncertainty, and use these plans in a way that progresses some proxy reward. Additionally, Cohen does not put confidence in current AI safety research paradigms, and even writes up an anti-review where he argues against each contemporary research agenda. In other news, Scott Garrabrand has discussed so-called frames, which he describes as creating an agentic first-person perspective on all third-person possible words, such as uncertainty, choices, and plausible worlds. He claims this is in contrast to the embedded agent's view and traditional RL with its environment-agent boundary separation. My Q, Liu and Techmark shows scaling laws of different function approximators and provide a taxonomy for precision machine learning. Michael Nielsen and Kanjun Ki have released their book Vision for Meta Science and describe the funders of research as a detector and discriminator in an imaginative research generation process. The Future of Life Institute has started a new podcast, and the latest episode with Ajaya Kotra covers how much AI might cause a catastrophe. This week, we also have a very few interesting openings available. So right now, Redwood Research is inviting 30 to 50 researchers to join them in Berkeley for a very interesting mechanistic interpretability research program. Also, Anthropic is looking for operation managers, recruiters, researchers, engineers, and product managers. Additionally, you can check out some of the new features on the AI safety ideas and join the interpretability hackathon from anywhere in the world next weekend. This has been the ML and AI safety update. My name is Thomas, and we look very much forward to see you next week.